Hi, welcome to Unit 6, Day 6, one-step mole conversion example in practice. So before you begin watching this video, make sure you take a moment to read the instructions that are at the top of your document. So you can go ahead if you want and pause the video now and read those instructions. Okay, so now that you've read the instructions, for these one-step mole conversion problems, as you know, there are essentially two main steps. The first step is to choose the right conversion factor, and the second step is to solve using dimensional analysis. Now, because these are very distinct skills, what we'll be doing is, for this first step in part one, we're going to do the steps separately. So for the example problems, we'll do step one, and then there'll be a separate video to show you how to do step two. That way you can practice each skill. So what you're going to do now is we are going to go, as I said, go ahead and do step one. So let's just review what step one is about. For step one, our main goal is to choose one of these three conversion factors, and we can either use the mole map or our understanding of units to choose that correct factor. So the first thing we need to do in order to do that is to read the problem. Then we'll identify the given and find, so what we're given and what we're asked to find in the problem. Then it's always a good idea to map out your plan, so actually write the given and the find out. So start by writing your given, then an arrow saying that you're trying to get to the find. Once you have that, you're going to choose the conversion factor that will allow you to convert from your given to your find. And once again, to choose that conversion factor, we can use either the mole map or you can choose it based on the one of these three based on the units. Remember, these three conversion factors are found along the arrows of the mole map. And then if your conversion factor includes the molar mass, make sure you use the periodic table to calculate it. All right, let's go ahead and get started with problem one. So we're going to start by reading the problem and then identify our given and find. This problem says convert 4.36 times 10 to the 25 molecules of CH3OH to moles. All right. So I've read my problem, now I need to find my given and find. Now the given will be the one that has the number with it, so this must be my given. And I'm just going to label that with a G. And my find, what I'm asked to find here is, I'm asked to convert it to moles, so I must be asked to find the moles. Okay. So let's go ahead and write that down as a plan. So for this problem, I plan to go from this given to moles. Now let's figure out what this given is. It's the number of molecules. This is literally a count of this is called methanol molecules. So I'm going from number, I'm going to use the hashtag or pound symbol for that, number of molecules to moles. Okay. So now that I have that, I can figure out what my conversion factor is. Now, if I use the mole map, what I'm going to do is I'm going to find out where I'm starting on the mole map. So number of molecules will correspond to number of particles. Okay? So I'm starting here and I'm trying to get to moles. So to get from number of particles to moles, I have to go along, I have to go through 1 mole is equal to 6.02 times 10 to the 23, Avogadro's number, right? So that's going to be my conversion factor. So my conversion factor is going to be 1 mole is equal to 6.02 times 10 to the 23. And in this case, since I'm dealing with molecules, that will be molecules as my units. So essentially, if you're using the mole map, you figure out where you're starting on the mole map and then use as your conversion factor whatever is written along the arrow that allows you to go from your given to your find. If you were using the list of conversion factors, you would base it on the unit. So in this case, I'm starting with number of molecules. Remember, the units here is the number of anything, any particles, molecules, atoms, whatever. So the units match, so I would use this first one as my conversion factor. Okay, so that's how we did the first one. We're going to do all of them like that. So let's go on to the next one here. What's the volume in milliliters of 0.982 moles of helium gas at STP? So let's go ahead and find our given and our find. So I have a number for this, so that's my given. And they're saying, what's the volume? So I'm looking for the volume. Now I can use that information to write out my plan. So my plan will be going from my given to find. So from moles, I'm given the moles, and I'm trying to get to the volume. And this is of a gas at STP. So using the mole map, I'm going to start at my given. So I'm given moles, so I'm going to start at moles, and I'm asked to find volume. And that means I'm trying to go here. Now to go from moles to volume, I have to pass through 1 mole is equal to 22.4 liters. So my conversion factor will be 1 mole is equal to 22.4 liters. Okay, next problem. How many moles are in 2.3 grams of neon? So again, my given will be the one with the number, so 2.3 grams, so that's my given. And how many moles I'm asked to find, I'm looking for the number of moles, so that's my find. Okay, so that means for my plan here, I'm going to write, I'm going from grams. Now grams is the units for mass, so instead of writing grams, I'm actually just going to write the word mass. Remember, when you see grams, that's a keyword that you're dealing with mass. Other keywords for mass would be weight or weighs. Okay, so I'm going from mass, and I'm trying to find the moles. All right, now I need to choose the conversion factor. So once again, if I'm using my mole map, I would figure out where I'm starting. I'm starting with mass, so let's find mass on the mole map. Here it is. And I'm trying to get to moles. So to get from mass to moles, this is the arrow that connects them, so I have to pass through 1 mole is equal to the molar mass. This is my conversion factor. Now, remember, since my conversion factor includes molar mass, I need to make sure I calculate that to get my full conversion factor, right? So for the molar mass, I need to get that from the periodic table. And here's neon. Now neon is a single atom, it's an element that has a single atom in it. So all I'm going to do is use the average atomic mass. That's my molar mass, right? I don't really need to do any calculations here. So I'm going to write here 1 mole is equal to, and that number I got from the periodic table, 20.18 grams. Okay, one last problem. All right, how many atoms are in 2.3 grams of neon? So let's go ahead and identify our given. That's usually the easiest one. It has the number. So I'm given grams implies its mass. And they're asking for how many atoms. So once again, many atoms, I'm counting the number of atoms, right? So that would be, it's helpful, I'm going to put a hashtag there. That's the number of particles I'm looking for. So I'm going to number of atoms. All right, so let's go ahead and see, using my mole map, if I can find the right conversion factor. So I'm starting with mass, and I'm trying to get to number of particles. Is there an arrow that directly connects these two? No. So in this case, this is not a part of a one-step mole conversion, all right? So we're going to put for these problems, anything that's like that that you can't find a one-step conversion for, TBD for to be determined, okay? And then when it comes to step 2, you'll leave that part blank. All right, so this is how you are going to do step 1. So follow the same procedure, and you're going to do that for these practice problems. At the end, when you're done, you're going to check your answers for these practice problems, either using the answer key, or you can use the video where I go through each one.